Hello, my name is Graham Allen. This is my demonstration project for MAE ECE 535. I'm going to be demonstrating the usage of capacitance in order to determine the liquid level inside a container. We're using two different methods, two different types of capacitors, in order to show the two methods and then some weaknesses of the method. First, I'll be using a parallel plate capacitor that I built, which will be submerged directly into the bucket of water. After that, I will be using a coplanar capacitor in which both plates are in the same plane and there's no gap in between them, which uses the fringing effect, as we discussed in class. The capacitance of a system depends upon the geometry and relative position of the two plates, along with the dielectric material that is in between them. This can be seen after applying Gauss's law and the definition of electric potential or voltage to the definition of capacitance of charge over voltage, as seen here. As the water rises, it introduces a higher dielectric constant into the system than it was previously. Air having a dielectric constant of 1 and water having a dielectric constant of 80, the capacitance of the system greatly increases as we fill the tank with water. Most of the wiring here is to run the LCD screen. However, there is a simple RC time circuit, and the system is monitoring how long it takes for a signal to go from the output to the input. And as the capacitance increases, that time will also increase. I also hooked up my parallel plate capacitor directly to a multimeter in order to attempt to measure the capacitance directly. Unfortunately, my multimeter is not highly accurate. However, this does show how the capacitance directly increases as the water level and the dielectric constant increases in between the plates. The next couple of clips are going to demonstrate the coplanar capacitor, which uses the fringing effect where the electrical field lines will bend in between the plates into the vessel so that the capacitor can actually be on the exterior of the vessel and doesn't have to be submerged. This has been rescaled for this capacitor. I'm going to slowly pour in water. As a final demonstration, I'm leaving the scaling that I set up for water, and I will be adding oil instead. The last clip showed how the dielectric constant of olive oil, with only a 3 being so much less than water's dielectric constant of 80, had a major effect on being able to read the level of the liquid in the container correctly. For practical usage, the circuit would either need to be set for a specific liquid and only that liquid, or it would need a more complicated multi-capacitor setup to be able to tell the difference between multiple dielectric constants and not be affected by different types of liquid. These capacitive sensors are used all across industry in locations where you can't use a mechanical or an optical-based sensor. They are extremely useful and are a great demonstration of Gauss's law and capacitance and how the changing only the dielectric constant inside a capacitor can have an immense effect on that capacitor.